Gosh darn it. Dadgum it.
That's two. You have to prove that and let it find something. It goes to another.
Yeah, see, it means it should be funny.
Yeah, I think
It just, you do the X to the, yes, you did. I'm so confused.
How's it going so far? Okay, so if it's ugly and requires, if you can mentally use subjects, that's fine. Many people can. Okay.
Yes, not.
I got an antiderivative of something like 1 over negative 2 natural log squared. Do you agree with that?
Yes.
Okay. 2 to the A.
negative 2 over natural log.
It is, you're right, thank you. No, it's power rule, so it'd be u to the negative third, and you raise it by 1 and divide by the new. So I think that's right?
Yes.
Okay. So the limit as a goes to infinity, I just naturally assume you're right, John. Yep, must be. 1 over negative 2 natural log of a squared. That's pretty rare, by the way. I would not usually assume that. And 2, maybe 1 over 2 natural log of 2 quantity squared. As a gets infinitely large, natural log of a goes to infinity, but because it's in the denominator, that term goes to 0. And therefore, this has an answer. I don't really care what the answer is. I just care that it's a finite answer. Right? You probably should say something like, I don't know, 1 over 2. I'll just say what it is. Okay? I don't really particularly care what the answer is because our series won't add to the same thing. I just care that it's finite. So what's my conclusion sound like?
Series.
The series converges because the intervals converges. They behave convergence-wise in a similar fashion, not necessarily to the same sum, but because that integral has a finite sum, the series also. You with me? Okay. On the homework, I'll come to the second one in a second. On the homework, I had a few people making, I think I talked about this the other day, but I'm going to say it again. Does the integral converging imply that the series converges? Yes, that's the integral. Okay. I just want you to understand that that is a one-way conclusion. If I give you this problem, not this problem. If I give you this problem, 1 over, from 1 to infinity of square root of x, whatever, square root of, actually I'll just go x to the 5/7 or something like that. You will not tell me this integral converges because it's like a p-series. There is no backwards to this. You should not ever say because a series converges that it will imply the integral converges. It's actually easier for a series to converge than an integral to converge because it's all real numbers versus discrete numbers. So this is a no. Never do that. Do not look to use that p-series, the series comparison to imply about an integral. That's a no, no, no. Are you understanding what I'm talking about? Okay, so if you had this problem, what would you do? You do it? There's no... It's already an integral. You're testing it there. Well, what are you talking about? So you would create an upper bound, do the whole integral, and see what the limit is. And that's your answer, right? Okay, so there's no series component to this. It's just integrated. It is what it is on its own. You with me? Okay, second large mistake, and I'm talking a large mistake that's going to cost you, is if you say this is P series, P equal 1/2 less than 1, converge, well, you will get 1 out of 4. Okay, because you have one part right, that it's actually divergence, doesn't sorry. Divergence, sorry. You would get the 1 point for diverge. You would lose everything else because you know nothing that is not a P-series. It's not a P-series. Okay? P-series is whatever constant, I don't care, over n to a power. Not minus 1, to a power, period. Okay? This is not a P-series. Please don't say that. It is like a P-series, which tells you should probably use a comparison test. Okay? It's like a P-series. So I'm going to say this one more time just to make sure you're totally clear. This and this. Like a P-series or is a P-series? Is a P-series. If it's a product, I can factor that 2 out. That's factoring the greatest common factor out. You're good. This is a P-series. P-series are like a P-series. Like a P-series, not a P-series. All right, understood? Okay, so then we say this is, we're going to have a little duke it out versus the P-series 2 over root n. I guess you could go 1 over root n, but 2 over root n goes nicer. So what do? You build up a comparison between the two. Okay, so let's start with something we know to be true, that the square root of n minus 1 is less than the square root of n. We know that to be true. Yes?
So for the first step of comparing the two, do you have to start at like a certain point, like 1's greater than 0, or can you just say?
I would say this is a good first starting step. Any more than that would be too much. Okay. I'll also say this in terms of, that student strategy. If you cut a few steps out of this in your homework, I probably wouldn't document, but I will be doing other tests later too. So,
That's okay, first step.
that's a fine first step. I don't need to say -1 is less than 0. Okay. Then I'm going to gradually build out what's going on here. I have a denominator thing, I have this 2 thing, I have this series thing. So if I, it doesn't matter in what order necessarily you do these, but is that true? If I divide both sides by 2, it's still true. Okay. If I take the reciprocal of both sides, is it true then that the other side, the left side, is greater? That's true. And then the series of all those terms. That's the part that I'm saying people leave out. That's not a dig at you. It's just people are leaving out a little bit, is what I meant to say. This is finite or infinite? It's infinite. Our series is greater than infinite, implying it must also be infinite. So here goes our conclusion. The series 2 over root n minus 1 must diverge. Why? Because it's greater than the series of 2 over root n, which diverges, and you must parenthetically say why you say that. You can't just claim it, you have to say why you say that. P series P equal 1/2 is less than or equal to 1. Okay. Anything? Yes.
Can you introduce the 2 into the proof at any time?
Yeah, I think that's the least restrictive of all, so yeah, I could go in anywhere. I think to put it in here, I think that's probably
I did in
pushing.
the very last step.
That's fine.
Like the big one.
That's fine, no problem. Okay, it's very liberal where you can put that. Okay, any other questions? Okay, now, this is going to be a working document, Carol, what I'm about to give you, but these series, if you haven't come upon it yet, then I guess it's time to realize it's a real big deal of Calc 2. In fact, you could say series is probably about 70% of Calc 2. It's a big deal, there's still a lot to come. I want to take this time to talk about where we're at and maybe give you a little taste of where we're headed today. So it goes like this. Call it a flowchart, a decision-making process. And then, again, this will be a working document. We're going to add to this, and I'll give you a nice, pretty copy before the AP test. But it goes like this. So you have a series. And the question is, infinite series converge or diverge is the question. You have all these different things that go through your mind. I want to not only review them, but talk about the order in which you should consider them. The first thing you should think or look for is the divergence theorem. The first thing you ask is, do the terms go to 0? That's the divergence theorem. It's the limit of the term 0. If the answer is no, then it diverges. You're done. If the answer is yes, then it might converge. You need to move on and go a little deeper. Okay? The next thing that goes through my head is it a known type? The answer that yes might lead to 3 different known types. What are some known, easy series types of here? P-series, okay? Is it a P-series? If it's a P-series, then what does the question become? What is P, and is it greater than or less than 1? We tested against 1. I'll just say for the sake of this, if P is less or equal to 1, yes, then the answer is diverge. But if the answer is no, then it converges. Okay? That's one known series. What's another known series? Geometric. Okay? In which case, what do we look at? R. Is the absolute value of R less than 1? If the answer to that is yes, then it converges. And if the answer to that is no, then it diverges. And what's the last one? Harmonics is a subset of the P-series. Telescoping, well said. Okay. Now I got to tell you, telescoping is actually pretty rare in the grand scheme of things. It takes kind of a math teacher fudging it to make it telescoping. Just because you see a fraction with some product on there doesn't mean it'll collapse. It's actually pretty rare. It's one of the least important ones. It's just easiest to handle at the start because that's why we teach it first. It's about if you decompose, does it collapse? And if the answer is yes, then it converges. If the answer is no, then you go back and start over. Actually, not all the way back. You just start back. Okay? Stay with me so far? Okay. So, say it's not a known series, a known pretty princess type. What might you then try? You might try an integral test, okay? The question for integral test involves, can you integrate it? And you integrate. Now, you guys can integrate a ton of things, and so the answer to that will be yes a lot of times. But stuff that involves factorials or stuff like those aren't integrable. They're discrete. They can't be integrated. So the answer to that in that case would be a no. If it's yes, you would use the integral test. And at this point, I think you talk about does the integral converge or diverge, and you make that conclusion based on the series. You with me? If the answer is no, I can't integrate it, or I'm not sure how to integrate it. Actually, there's one thing I wanted to get into. Sometimes, when I say divergence theorem, it says terms. Do the terms go to 0? There's some cases where you're not going to know. You're not sure if the terms go to 0 because it's really complicated. So if it's yes or unknown, then you proceed on and say, I'll figure it out later. Another test will tell me. Okay? So if you're not sure about divergence theorem, proceed on. Back to this thing. If it's can you integrate? No, then the answer might be use a direct comparison test. What's the question that goes through your mind as to whether to use that or not? Is it like, and by virtue of add or subtract, a known? That might be like a geometric. If I had 1 over 7 to the n minus 1, that's not geometric, that's close. Or like a p-series. If the answer to that is if it's like by virtue of adding or subtracting, you might then use a direct comparison test, and we know how that goes. If the answer is no, then at this point before today, you'd say, oh, I guess that's all I know how to do, so I'd stop. But after today, you're going to use a ratio test. You might say, does it have factorials and or exponentials? If that's a yes, you would probably say, try the ratio test. I'll talk about that in a second. If that's a no, And you might say something like, does it have stuff to the end, but it's not quite geometric? Then you might use the root test. Oh, it's lots of fun. They're super easy because they have the same test value. All right, so that's today's lesson. There are 2 extra tests that let you go further. Here they go. Okay. Oh, no, sorry. That? Yes? Down? What? Do you want? This again will be, I'll come back to this. Maybe I should have. All right, you with me? Okay, so the ratio test. The ratio test is a way of not going one better than the divergence theorem. It says do the terms get smaller, but it also says do the terms get smaller fast, which helps you convert, okay? The idea is really straightforward. You look at the general formula for the terms, and you compare the general term to the one after. Now, I know that if these are decaying, then what should happen in that ratio? The one after it should be more or less than the one before it. Less. And so that ratio should come out to be less than 1. And that is the test value. If that ratio is less than 1, then the series will converge. And not only says they're getting smaller, but they're getting smaller fast. If the test comes out to be greater than 1, now that usually indicates that the terms are getting bigger, and it probably was failing the divergence theorem. I just couldn't figure that out. All right, so that'll prove divergence. And if it comes out to be equal 1, which happens, then the test fails, and you have to use some other test. All right. So less than 1 is converging. Greater than 1 is diverging. Equal to 1 is inconclusive. Are you ready to see how this works? Okay. So the reason I would use a ratio test here is because it has factorials and exponentials. It's not straight up geometric. The factorial makes it a little more complicated. You'll see why the ratio test works here, but it involves a lot of canceling. Okay? So if you were to look at the n plus 1th term to the nth term, let's start off easy. And the nth term. Well, the nth term is just the general formula. N factorial over 7 to the n. Actually, take it back. I already screwed up. What's the first thing I usually do? In a series problem, what do I usually do? Divergence theorem. So this is what I should have emulated. I made this example, so I kind of already know this is not happening, so that's why I kind of forgot to look at it. But in terms of does this get smaller or not, we don't have a lot of factorial knowledge yet. So the answer might be, I don't know. So because I don't know if the terms are getting, do you know? Factorial is pretty powerful. When I say I don't know, I mean you don't. I know. The factorial is more powerful because the exponential means you're always multiplying by another 7. The factorial means you're multiplying by another bigger 8. So the factorial win there, that says that it's probably divergence here. But let's say we didn't merge. Are you with me? Okay.
Question.
Yes.
The first thing limit, is that a goes to infinity or n?
That's n. This n goes to infinity.
No, not that one. Up. That one like.
That's it. N. Sorry. My bad. Okay. So the n plus 1th term is n plus 1 in parentheses factorial over 7 to the n plus 1. If you put n plus 1 into the formula, what do you get? Are you with me? Now, again, you got to strike a balance between being thorough but not spending your whole life doing your homework. So you want to show what needs to be shown, no more, no less. I'm going to show maybe a couple steps extra, and I'll communicate to you. Maybe you can consolidate these two. In terms of what I could clean up, I could start by saying reciprocal. Right? Now you'll see the point of this is largely a whole ton of dividing out factors. Cancel, cancel, cancel. Okay? It's the case that you want to focus on the larger term, take the larger term down to the smaller to cancel. Okay, you're going to rewrite this a little so you can get a little canceling action. N plus 1 factorial. It's n plus 1 times n minus 1. So n plus 1 factorial could be rewritten as n plus 1 times n factorial. Do you see where I'm coming? That's a huge idea. You got to know it. You see where I'm coming from? Okay. Now, by doing that, that obviously allows us to knock those babies out. Same goes with the 7 to the n plus 1. How could I rewrite that so that I could get a little canceling? 7 to the n times 7 to the first. I guess you could also use the different. I like that. Okay, the 7 to the n's divide away, leaving you with the limit as n goes to infinity of n plus 1 over 7. What does that go to? It's infinity. Okay, now here's where the test conclusion comes. You have a lot less writing to do in these. You show the limit result and you show the test value. In the ratio test, we test or show how it compares to 1. This is greater than 1, so the series diverges. You must show the result and how it compares to 1, the test, and then conclude. Okay, you with me? Okay, try the next one and see how that goes. Here goes. Feel free to do that on the test so I know where you're at. I'll also let you slow people know you're way behind, that you're not at the whoosh.
Yeah, the bell rings.
Got to the whoosh. That E will be a little bit of a mess for the n plus 1. So that's one of the ones I'm looking at. So I don't keep working, but it is totally fine if you take the reciprocal step and the cleanup or break it up step into the same. That's fine. You can do that. Sorry, I neglected to explain the whoosh. Please don't go to college also and do that. That's not universal. Okay. So you're getting cleanup that looks something like what I've got there? Okay. So eventually the E partially drops out, and you have n plus 1 over e to the 2n e to the first. What goes faster? The denominator, so this limit is 0. Now you test against the value, which is 1. That number is obviously less than 1, so we conclude the series converges.
Nice.
Okay. Okay. Now, I again failed to show the divergence theorem went to my mind. I should have started by saying, does this have a chance? Failure to go there, failure to do the divergence theorem will never get you the wrong answer. The worst that can happen is it could have been easy and you didn't see it right away. You went through all this work and you could have seen right away the terms didn't go to zero, so you had no chance. So divergence theorem really should be a habit because at the best it will save you some time. You with me? All right. The ratio test, or the root test, excuse me, this is one of those, I kind of like it. I used to be a mechanic, and so it's kind of like that tool that you don't use very often, but when you need it, you really need it. That's kind of the root test. It comes in handy once in a while, but it's super handy when you need it. The idea is that if you take, as the terms get huge, you take the nth root of the terms, what happens? There's this play here. Imagine something like this. 1 over n, whatever. You wouldn't use it here, but actually something like this. That's how supposed to be? Ouch.
Yeah, you made it clear.
That's a real critical. Okay, actually, your handwriting's pretty good, so you can criticize me.
That's why I'm a mechanic.
That's all you did. And I was staying very
I
quiet.
don't actually listen to your questions. That's what I want. I worked at Hyundai. Yeah. My dad owns a garage, so that's what I did. If you leave college and have no idea what to do, it's fun. I had no idea what I was supposed to do. I worked as a mechanic for 5 years, and I didn't start teaching until way later. Don't worry. Don't let people tell you you're supposed to know exactly. That's correct. It took me a while to do that. So, you what? I mean, you're gonna waste your money if you don't, like you're not gonna.
How much do you charge for brakes?
What do you got?
James is serious.
What do you got?
Mine just like, my car is 12 an hour. On my other car, I'm like,
75 an hour.
what?
I'm like an SUV.
75 an hour.
75?
That's cheap.
Yeah.
You should go there.
I know a guy that does brakes for just the cost of the brakes plus the.
I got, actually, they're not very soft hands, but, yeah, they're not. I'm a gentleman, man. I don't do that stuff. All right. So here's the idea. So that's the lesson at hand. You take the nth root of the term, and you say what happens. Now, the term's usually the question is, as the terms do their thing, what is the nth root of that? If you take the nth root of stuff that's more than 1, then there's this fight between the root makes you get smaller versus this is getting larger. It's hard to say. But it's all about when you square root or nth root numbers, what happens. If you nth root something and the terms or the nth root is less than 1, then that actually means the terms are getting small pretty fast and the series will converge. Not super fast, but fast enough to converge. If the nth root is greater than 1, then the series will diverge. Now, because of that, it's kind of like the ratio test. It's nice that the conclusions are exactly the same. Equals 1 is divergent, or inconclusive, excuse me. So, it goes like this. When would you use it? You use, did I say when you should use this somewhere? Okay, would you put this in here? Use the root test when you have something that involves an exponent, but more, so it's not just geometric. Okay, if it was just straight up, 1 over 7 to the n, I wouldn't use the root test for that. It's geometric, I'd just do my geometric thing. But in a problem like this isn't geometric. This has that geometric component, but more, so it's not geometric. If that's the case, then you might consider this root test. Are you ready? Okay, so it goes like this. Actually, I'll do the first one, it's easier. I'll let you do the second one. So the idea is I take the nth root of the term formula. The nth root of the term formula. Can you look at, can I what?
Why would you take the N and the F value?
Why here? That is the root test, the nth root. How does it work? That I have to explain. If you want a quasi-proof of that, I can talk to you about it.
Because you're raising it to the N.
It's already to the end in the problem. This is the root test. Okay, it already came to the end. I didn't, it would be stupid to nth root it and that, you're right, that would be weird. But that's not the question. It was already there. Okay, so what is the limit as n goes to? Actually, let's just clean it up here. What's the limit as n goes to infinity?
Wait, A or N?
Oh,
I get it.
Two-thirds.
Oh.
I was like,
What did they cancel?
with the
Oh, wait,
The
no, that was.
nth root and the nth power cancel, right?
Oh, that's 2/3.
two-thirds.
Right?
Two-thirds.
Okay.
Yes.
I feel like I lost some people, have we?
You almost lost it.
Okay,
Copy tax bill.
so 2/3, now the test value, that is less than 1, so the series converges.
Oh my God, it's so simple.
Yes, it is.
Oh, this one.
Okay, the next one's a little harder, yes.
Same thing as the no.
It isn't because there's no input for it. I'm using the conclusion that help us along the series. That the conclusions and the test values of one are the same, but in terms of what you're doing to get that limit is totally different. Nth root versus initial. Okay? Yes? No. Yeah, I don't know what the sum is, and I don't care. I just know what to do. Okay?
That's how it's
Okay. This one's a little harder, so I would normally say go for it, but let's try it together. Okay. What tells me, if I were doing this on my own, Hades, the root test, is that to the end, but with a little more. Okay? So I'm going to use the root test, and it goes the nth root of that. Now, can I, do rules of math allow me to root each of those separately in a quotient?
No.
Yes, no? They do. Okay? In the denominator, what's the nth root of 5 to the end? 5.
Yeah.
That helps a little. But now the top is a little messy. If I rewrote this as a power, isn't it something like n to the what power? What's the root power? 1 over n. As n goes to infinity, the denominator goes to, or the base goes to infinity, the exponent goes to 0, and is that, it's 0? It's indeterminate. It's fine. It's fine.
It feels like zero.
Okay, you're right. So,
Wait, what is it? Wait.
Like, that feels like a zero.
which part?
Wait, the N.
It's definitely a zero.
The nth root of n is the same as the 1 over n power. Just like the square root is the same as the 1 power.
What's your gut feeling?
Okay, so if I were to use my skills, it's fine. It's a really easy one. Okay. Now, notice that the 5 is done. 5 is 5. I'm focusing on the limit at the top.
So we can put that up front.
You can put that up front, you bet. Okay? 1/5 e to the limit as n goes to infinity of natural log of n over n. That is still indeterminate. And so by L'Hopital, oh, for Pete's sake, I think you can handle the derivatives there. What's the derivative? 1 over n, which goes to
0.
0. So our final answer is
I was pretty close.
1/5. You're correct. The limit was 0, which is
Less than 1.
less than 1. So the series converges. Okay, that's the root test and the ratio test, and when to use them. Are you with me? Yes. That's the part, I gotta be honest with you, that's the hard part to explain. I think what I'll do maybe, it helps to look at an actual calculator and table values if you look at a real problem numerically. And how it is. So I'll try to get to that tomorrow. Which I don't like teaching this way, but from past it's okay. Okay. Questions on the area? Let me give you the answers to 129 extra practice. Here we go. We have about 8 minutes. I'll at least give you the answers and check it tonight, and we can go over more questions tomorrow. Are you ready? For number 1, I got pi. Okay. For 2, I'm talking area outside the far right region. B is the area inside both. It's the sum of 2 separate regions, so that's the area inside both. You should be shading the common area.
You gotta do those like things.
The spokes, yeah.
Spokes.
The spokes.
It says to 5 over 3 on our worksheet.
For
For C.
C, yeah. C you can scrap because I think what I had there was
It only goes to 0.
bogus. I changed it. This is my next change. So don't worry about C.
Okay.
For 3, you should have a couple peanuts, yes? And the intersection are pi over 8, 5 pi over 8, 9 pi over 8, 13 pi over 8. The area in C, I got 8.4803.
We got all of
And D, 11.3137. Do you agree? Okay. Moving on to the next one.
No, we just one.
Okay. Tonight I'll just check for effort. I fully expect you to miss some of them, if not all of them. I just wanted you to try. It's very much a learn by fire. Okay? All right. So for I got one wrong. B is pi over 3 or 5 pi over 3. I guess I could also take negative pi over 3 as pi. And you're cool? Backside? Ready? Okay. Now, in this case, the area was meant to be, what kind of line could you draw, or where could you draw it to get exactly 1 unit of area, 1 square unit of area inside that circle? That then is your answer. And angle or A of 0.1256. That's an angle. Okay? How'd that go? Okay, ouch. 6 I thought was the hardest one. 6 I had 8.3377.
Wait, there's no calculator.
This is no calculator.
Without
Sketch the curve.
What?
Okay.
I hate my life.
I'm just checking for you. You did it. You tried. Okay. I don't expect that you did it well. I just expect you tried. Okay. That's how you're going to learn this stuff, is to try and fail. Okay? Or just try and succeed. 7. 7. Oops, sorry. 7 should be something like a rose like that. A circle like that. And then the area is 0.30709. Okay, 8. My answer is, oops, that's not 8, that's 9. Where's 8? Do I not have 7? Oh, 7 I already gave you. Okay, 8. I have 1/2. Okay, 9.
That's kind of funny.
That's the answer. 9 is pi cubed over 48 is decimal. That is.
I killed 9.
That's good. killed it in a good way, right?
Yeah, no, killed it in a good way, like I got it.
48. I have 0.6459. Yes? Okay. And for 10, I have 14.5978. A lot of people missed out on the last class. I thought that was the easiest one.
You brought back the easiest one.
I thought this was the easiest one. The peanut was almost all outside. The rose only touched here
Oh, was it?
and just touched. It didn't go outside. So I just did area inside peanut, area peanut, minus area rose.
The three-pronged.
All right. How'd that go? 10 out of 10? 8 out of 10? I would definitely do that. That's good.
What did you like? 3 out of 10.
3 out of 10, you're just like everybody else. You should learn. Well, not everybody else, but you're doing fine. Just learn from your mistake.
I have data.
You have time to maybe go over one. You have a question on one of them?
Everyone.
3? Sure. Okay.
Let's do 8 to 7, please.
All right. I heard. Oh my, 3. What did you say? 5, 6, and 7. 3 might take a little longer, so I'll come back to that. What about 5? Okay. How did you set up 5? Did you? First of all, did you understand the nature of the question? Okay, based on where this is, it would make more or less area, right? You with me? So let's talk the area inside there. How do you find the area? 1/2, because there's no symmetry to this. From 0 to A, we don't know. 4 cosine theta quantity squared. In this case, we know it to be 1. Can you just put that in your calculator? Probably not, huh?
Wait, how do you know it's 1?
How they tell you?
But I put 1.
1 square unit. So you thought that U meant something else? A lot of people think, what is the U mean? It's just square units. Yeah, no, sorry. In the future, I'll write square units. Sorry, you're right. There were a lot of people that weren't sure what that U meant. So that was the issue? Okay.
I got that, but still got it wrong.
Okay, so I wanted to get this to a place where at least I could use my calculator, but I didn't feel like I was there yet. So I integrated this. This is 8. And then by power reduction, I went something like the 1/2 minus 1/2 or 1/2 plus. Isn't that how we do power reduction?
One less minute.
You with me? Do you see where I'm coming from?
Yeah.
Okay, so if I take out the 1/2 and integrate, that's 8 over 1/2, so 4. And the integral is something like theta plus 1/2 sine of 2 theta from 0 to A equals 1. Cool? So 4A plus 1/2 sine of 2A minus 0 plus 1/2 sine of 0. You only have 5-minute passing period with me? So I then picked up my calculator here. I graphed this.
Oh, you did too. I didn't
Is
see
that
the second.
the graph y equals 1?
Okay,
And
okay.
find the intersection.
Well, I got long.
So it's that area.
I understand that. It makes sense if you think about it.
That's right. You just
Where it goes.
This one now?
Put it in
Or
your
the 1/2 from the actual integral?
I got something you can make. I'm all.
Have a good day.
I like to read it.